Thank you very much, Mike, for the introduction and introducing me. My name is Bahi. I head the solution engineering team for Xage across the EMEA region. Thanks for the organizers again for having me here. So without further ado, let me share my screen and then start the presentation. Okay, excellent. So today I'm going to talk about a very interesting topic, which is autonomous operations and how to secure them. So autonomous operations by itself is an interesting topic, and how to secure them is even more interesting, right? So this is what we're going to talk about. Just to make it clear for everybody, I mean, it is a 25, 30-minute sessions. So we're not going to cover everything around autonomous operations and their security, but we're going to highlight the most important, I would say, requirements to build a fully autonomous operations where security becomes very important and very essential at every stage of that process and that journey. So let's get started. So basically, I would like to start first of all to explain to the audience what is autonomous operations and what are the benefits that we can get or operators and industrial operations organizations can get out of it. And then what are the essential requirements? There are more requirements than those three, but what are the key requirements for achieving autonomous operations, mainly around the data intelligence, the supply chain integrations, as well as the ability to adapt and recover without any human interventions, being completely autonomous. And then we're going to talk about the next steps. What is the path forward? How can we start that journey? And what will be the logical sequence of getting there? So to start with, autonomous operations basically have been a concept in the last few years, but started to become or to started to turn into a reality nowadays. I have had very interesting conversations with industrial operations, mainly in manufacturing as well as in warehousing, who started their strategies around how to move towards fully autonomous operations. So to start with the definition first, what is autonomous operations? We have, I'm not sure everybody is aware of that, but today we have autonomous devices that can perform everything by themselves without any human interventions. And that model have evolved into autonomous processes, and then that have evolved into an autonomous systems. Those exist as of today, robots, autonomous cars or vehicles are great examples around that. Now, industrial operations, if you want to talk or take manufacturing as an example, is not a single or individual systems. It's what we call it SOS, system of systems. And that's really much complicated to move into an autonomous state out of the automation state that we have as of today. So today we are at the automation. I'm going to talk about the spectrum evolving from the manual to machinery to automations, and then the use of AI towards the autonomous operations. But we'll cover those in the next slide or so. So this is about autonomous operations, is to have a complete operations involving the OT plants, the IT management systems, the supply chain, the data, the human resources, all managed in a very autonomous manner without any human intervention. That system will have the ability to adapt, recover, make business decisions, avoid mistakes, be more efficient in terms of production, revenue generations, and stuff like that. So these are some of the benefits. I already started mentioning them. Gain a competitive edge in the market, increase protection or production, utilize data and AI in making business decisions across all the levels, not only in the operations field, and of course optimize the supply chain, which I believe it's one of the most difficult steps to achieve towards autonomous operations. And of course, address the challenges that we see today's, the safety challenges, the risks that I would say the laborers face in the field, the shortage in the skilled labor that we have in the market as of today. So also to reduce the cost and the downtime, and of course to increase the revenue. So I don't want to really talk much about the history, but we know that the spectrum of human intervention in operations have been, I would rate it maybe from 1 to 5, 1 being fully manual, 5 is fully autonomous. Today we are maybe, I would say, at number 4, where 1 is fully manual, 2, where the human will take control of everything, and there are some I would say, assistance from the machines, repetitions, automations, and stuff like that. And then number 3 is still the human being takes control, I would say, of most of it, and the machines, like autonomous, I would say, vehicles, assist the driver to auto brake or make lane changes or stuff like that. Level 4, where the machines, let's take an example again of the autonomous vehicle, where the machine automatically drives, but the driver has to be there sitting and just take actions in the emergency or the critical cases where intervention will be needed. Now, it is the same way today in the industries, and I would say, and I'll pull after this slide to ask the attendees what they think, where they are, at which stage they are within their industries today, or within their organizations. Where today we are at the automation, AI started to get into the picture here. It's a rule-based. Human is still in the loop. There are a lot of things, a lot of systems being automated in the operations, especially in the field, but still the human is in the loop to oversight and interventions, for safety, for maintenance, for emergency cases and stuff like that. And to move from, I would say, industrial automation into industrial autonomy, those points, safety, supply chain challenges, maintenance risks, have also to be taken care by the system itself and by the autonomous operations itself. So the human is completely out of the picture here, and the whole operations is a human independent in a full autonomy. So let's stop here at the first poll and ask the question, how much human intervention is required today in your sites or in your operations? I'll be glad to see your answers, but I can kind of guess it's not going to be, of course, the first one, and I don't think it's going to be the last one. It's going to be maybe somewhere between 2 to 3 or something like that. So glad to see your participation here. And I know it's a journey. Autonomous operations, it's a journey. Is not like something that we can achieve overnight. And there is no, I would say, such a technology that can help us achieve that. So shall we go through the answers? Or I can see that most of you have answered, none of you have answered completely autonomous. As I expected, most of you between 2 to 3 or both of them together. And still, I can see a lot of things that are being done manually today by you guys. Glad to see that participation. Thank you very much. Now let's move on and start talking about what are the key requirements. As I mentioned earlier, there are more than 3 requirements, but I'm going to focus my presentations on the main 3 because of the time constraints here. So to achieve autonomous operations, data intelligence or data-powered intelligence, or what we call it today in a simple term, artificial intelligence or AI. AI has to come into the picture, and we need to integrate the supply chain into the operations. And the operations must reach to a state where it can or it has the ability to learn, to make decisions, to recover and adapt automatically without any human interventions. So let's start shedding more light into each one of them. Let's start with the data powered intelligence. I think, or I believe, it's one of the most important requirements here for autonomous operations. So here, when we talk about the data, when we talk about artificial intelligence, we need to focus on a very important topics, and this is also very important from a security perspective, which is data integrity. We need to ensure and to apply I would say, the measurements and the technologies that will guarantee that the data sharing between the operations field, which is the plants, where things are getting manufactured and stuff like that, that when we enable the integrations on the IT side of the business, the management systems, the business applications, the supply chain management, the human resources on the IT part of the systems, the data that we have collected into the analytics tools and the decision-making algorithms must be accurate 100%. You know the very common saying, garbage in, garbage out. The quality of the data that you're getting should be equal to the data that you are getting here, where data authenticity, data integrity measurements has to come in place. And as I explained in the definition of autonomous operations, it's an enterprise-wide operations and managed by enterprise-wide signals. So you cannot rely only on a subset of a data from one part of the network and you start making decisions. So as I mentioned, it has to be a fully integrated from the OT sides. Data has to be coming from the data sources like sensors, OT softwares, PLCs, SCADA servers, DCSs, and stuff like that, and fed into the AI algorithms, which most likely will be running in the cloud due to the high computing resources requirements. Same thing, the data that is coming from the IT and the cloud, like supply chain management, customer support, ERPs, financial data, business analytics, and stuff like that, has to go into those, I would say, algorithm to be for the autonomous operations engine to be able to make decisions, adapt to changes, send the I would say the right commands to the operations fields to do its job. So it's all about data integrity and data authenticity here, and that would also require an integrated or integrations between IT, OT, and the cloud for the reasons that I have just mentioned. And that's a great chance, again, to Paul here and ask you how integrated are your IT and OT systems? Is it still fully air-gapped, or there is a certain integrations in certain areas, it's fully integrated in the matter of, I would say, industrial automation? Okay, let's see. I don't expect it to be fully integrated. Maybe somehow isolated, but I would say for remote OEM support, all of us, we have seen what happened to all the industrial operations during COVID-19, where we needed an immediate support from overseas, where people weren't able to travel. So as I expected, somewhat we integrate and analyze signals across the system. So that tells me that we started, or you guys have started the journey towards autonomous operations, maybe on different levels. But yeah, I mean, I don't see anybody who says our IT and OT systems are fully air-gapped, they are not integrated at all. So now let's move into the next slide, which is how to secure the integrated enterprise operations. Whenever we have an IT-OT convergence, from a security perspective, we cannot rely on the traditional network security approach. You know, if you are relying on something to block traffic or contain, I would say, certain data in a specific network, when you want to move into a complete autonomous operation or full automation and data sharing between your IT and OT networks, you cannot keep relying on the same legacy methods, the network segmentation approach that we have used to use, like firewalls, VPNs, jump hosts in IDMZs and stuff like that. We need to really also to develop and evolve the type of technologies that we use and move into what we call it an identity based approach. Instead of a network segmentation approach, we need to move into an identity based approach where every element within the network, being IT, OT on the cloud, needs to have a unique identity and needs to be authenticated via unique token or credentials to be able to communicate and share data into the network. If we remember the last slide, we were talking about data integrity. In autonomous operations, you cannot have the chance to send the wrong data to the wrong party. That's why you need to rely on advanced technologies to evolve your IT OT communication security with tools that are asset agnostic, protocol agnostic, an architecture that is secure by design, tamper proofing, and of course, flexible deployment that can span across OT, IT, and the cloud, because as we agreed, we need to integrate our OT shop floor with the IT business management systems and most likely feed into the artificial intelligence or AI tools or AI algorithms that are running in the cloud. Now, this is from a data perspective. I tried myself to make it in a way that is easy to digest, easy to understand, from architecture point of view as well as from a security perspective. Now, let's move to the second requirement, which is supply chain integrations. And believe me, this is one of the most important and one of the most difficult requirements to achieve. But in order to achieve it, it has to go on stages. We don't want to move overnight from an autonomous device to autonomous operations. It has to go an autonomous device to autonomous system to autonomous process and then to autonomous operations. So we need to take it one by one, step by step, start integrating your raw material supply systems, your suppliers systems, management systems, to the factory, distribution, retail, customers, one by one into the whole, I would say, integrated operations that can go through, of course, data sharing from all data sharing and data, I would say, generation. You generate data and you share this data and you get a feedback from those systems through the stack of data, cloud, AI, and vice versa. Now, to secure the supply chain data, securing the data exchange between the different parties is of an extreme or a paramount importance. Data exchange must be secured in a zero trust architecture where I mentioned every element being a data source, being a human, being a device, being a machine, needs to be authenticated and with granular access policies enforced on those assets. The person who needs to send data should have the permission only to send in a specific queue topics, and the person or the entity that need to receive the data must have the permission only to receive. And this will help you avoid unwanted data being shared with unwanted resources and stuff like that. Multiple factor authentications need to be applied for those, I would say, interactions between users, suppliers, factories, and stuff like that. And that will automatically, and the objective of all that data exchange security, integrity checking, authenticity checking, authentications is to prevent the intellectual property leakage or theft, malicious actors, insider threats, competitors who might get access to your critical informations, and also to protect your customer information that is already stored in your systems. And in many breaches, you hear that organization A or B got breached and like thousands or hundreds of thousands of customer data were published on the internet. And of course, to limit the blast radius of malware, I have seen in the news that, and specifically in the manufacturing industry, that they were hit with ransomware attacks that caused an interruptions or I would say a loss of this amount of money because the production and the ability to produce the goods were interrupted for weeks or days or stuff like that. And even shipping companies in the logistics and warehousing and also were facing those issues. So the third questions, let's pull number three. What are your greatest concerns when it comes to supply chain risk management? What are the cybersecurity risks or the risks that you always worried about when you deal with a supply chain? Is it preventing the IP leakage? Is it protecting your customer information? Or is it limiting the blast radius of a malware hitting your operations plants and interrupting your business and production lines? What is it that you think it's really that you wish not to happen? I'm not sure all of them, but what is the most important one? Okay, let's see. We are getting some of the expected results here. Supply chain management or supply chain risk management becomes a responsibility for every CISOs nowadays because without your supply chain management, the whole, I would say, business might be interrupted. So interestingly, protecting customer information becomes the highest priority, and of course, IP leakage as well as limiting the malware and ransomware blast radius is another important topics here. Great. So let's move to the last part of the presentation today. The third requirement, which is the ability to adapt and recover. And of course, one of the most, I would say, promising technologies and concepts that came into the market is what they call it a digital twin of your physical assets or physical operations. The definition of digital twin is simply that it's a virtual copy of a system or a process or an operations that mimics the actual operations in real time. So basically, the digital twin is a virtual copy of your operations, but it's in real time. It means it can simulate what's going on right now, and it has a historical data of the plant performance, what has been done or what's happened and what has happened, and what we expect to happen or predict to happen or what should happen in the future. And this is a great advantage for every operations that is trying to move towards autonomous operations. Why is that? Because there are a lot of activities that you cannot perform on your physical assets because you don't know what you cannot expect or you cannot predict what will happen, and you will be worried about interrupting the operations. Things like from a security perspective, running a red team exercise or running an attack simulation exercises against your plant to be able to adopt a protection first approach against the cyber attack and the cyber risk against your physical assets. You will be able to do that, and you will be able to do it in an accurate manner because the digital twin of your operations knows the history, can simulate the present, and based on what's going on, it can give you the expectation or the predicted results that if you perform that, you are going to get this and that. So the idea here is that it has a huge benefit in terms of digitizing and moving towards an autonomous operations for the digital twin. Now, one of the best approaches to secure the operations through the digital twin is to apply what we call it a zero trust strategy, focusing on prevention. Let's not wait for, because it's a digital twin, you can apply prevention, you can block attacks, you can take preventive measures on the digital twin that can be applied without any concerns or without waiting for a long time for a maintenance window to apply that on the physical operations or the physical assets. So zero trust approach allows you to contain and prevent cyber attack before they get into your operations, and without really having the hassle of trying to detect them, analyze the data that is being get. A great example that is very common, and I can see Mike open his video. That is a sign for me that I have to finish now. Uh, maybe a minute or two, Mike, if you allow me. So the incident containment of a ransomware example, with a detection and visibility-based approach, you will need to wait for the initial access, discovery, data exfiltration to be able to trigger that there is a malware attack that is hitting our plant or not. While with a preventive-based approach or a zero trust approach, that kind of activity will automatically be blocked at the initial access stage because there will be no credentials. Credentials are not static, they are rotated, and access or discovery will completely be disabled at the first place. So you will not reach to the level that you need to detect something within your plant. And the last couple of slides. So there are incremental steps that you need to take to achieve or to move from automation to autonomy. Basically, we need to think with the future. We cannot really rely on the legacy applications and the tools that we have been using before. We need to improve visibility and granularity, detection controls, data security, and data exchange. And then, as a conclusion, autonomous operations is an end state, so it's a journey, and we need to think or to take the first steps that we discussed in the past. There are three main requirements: data supply chain and human-like responses, adaptability and changes. All of them require security to be at every stage, and preventive security with a zero trust approach is a first good step to secure your journey towards autonomous operations. And thank you very much for that. Over to you, Mike.
Thanks, Bahi. Yeah, I wanted to make sure we got to a couple of questions. I know we only have about a minute left. So there's a couple of questions. I'll take the one that's kind of a combination or a little bit of all the other ones. So if we take human complexity out of the loop, aren't we taking on a huge risk? Can we expect the machines to manage safety risk, cyber risk, along with inherited risk from AI, like data poisoning, hallucinations, and so on? What happens when it goes rogue, like with Skynet?
Yeah, so today, if you think about it in a less critical environment today, like AI being used across cloud computing, across IT-related activities and stuff like that, they have been completely taking the place of the humans and the real employees. I'm not saying that tomorrow or in 2 years we have to be ready for a fully autonomous operations. But there are measures, there are activities that and steps and requirements that we need to take. A great example that I can mention here is the digital twin. The digital twin will tell you what's going to happen if you do this, and it's going to tell you what are the action that need to be taken towards that I would say change or activity or adoption or whatever. So in other words, we expect the machines or the autonomous operations to be more efficient, more accurate, and more advanced, less risk, and more safer for the operations than the human beings, because there are human-prone errors and mistakes and stuff like that that nobody can avoid.
Absolutely. But Bahi, thanks again for coming and sharing with everybody, and thanks for attending. And I know we got one more session before the wrap up, so we'll see everybody over there. Thanks again, Bahi. All right.
Thank you very much,
Have a good
Mike.
one. Take
Bye.
care.